So let's bring some things together and talk, bring the topics that we did so far, and talk about graphing rational functions by hand. So what do we know how to find so far? We know how to find X-intercepts, you set the numerator to 0. We know how to find vertical asymptotes, you set the denominator to 0. We know how to find the horizontal asymptotes. You take the ratio of the leading coefficients if they're both the same degree, otherwise it's either 0 or there isn't. And I guess the other thing to keep track of is Y-intercept, but we know how to find Y-intercept for anything. You just plug in X equals 0. So let's try to use those facts to graph these rational functions. We get something that qualitatively looks correct. We'll acknowledge the things that we don't know. And then maybe we'll get a computer graph and see if it looks reasonable. So let's try to graph this. X plus 1, X minus 2 over X plus 2, X minus 1. We didn't do this already, right? Okay. So, let's start by finding the X and Y-intercepts. Maybe the Y-intercept is the easiest. How do you find the Y-intercept? Set X to 0. So, let's find the Y-intercept. Maybe I'll give myself workspace off to the side. Y-intercept, you set X equal to 0. Plug in X equals 0. 0 plus 1. 0 minus 2. 0 plus 2. 0 minus 1. So it's negative 2 in the numerator, 2 times negative 1, negative 2 in the denominator. So where is the Y-intercept? And if I write it that way, I don't need to say Y-intercept because that's the y coordinate, that is a Y-intercept. Drawing it, that looks like a reasonable thing to call 0 and 1. How do you find the X-intercepts? Or alternately, just where are the X-intercepts of this function? Do people agree? Without showing any more? Nice. So I guess that's about there and there-ish. Let us find the correct vertical and horizontal asymptotes. And I guess the next thing on the list is vertical asymptotes. So either, how do you find the vertical asymptotes, or where are the vertical asymptotes? Set the bottom to 0, set the denominator to 0. Vertical asymptotes. X plus 2 times X minus 1 equals 0. And what X value solve that? Okay. So I should have a vertical asymptote at X equal to 1. A vertical asymptote at X equals to negative 2. Either, how do you find the horizontal asymptote, or where is the horizontal asymptote? Do people want to review how to find the horizontal asymptote? Okay, cool. So, the review is going to amount to just me flipping to the previous page in the notes and reading off the thing. So maybe keep in mind the function in question, because we'll need to decide which bullet point we're in. If the degree of Q is bigger than the degree of P, are we in a situation where the degree of the denominator is bigger than the numerator? No, so we can ignore the first bullet point. If the degree of P is bigger than the degree of Q, is the degree of the top bigger than the degree of the bottom? No. So we're in the middle case. Leading coefficient of the top divided by leading coefficient of the bottom. So we need to just determine what the leading coefficients are at the top and bottom of this rational function. And it looks like that would require like boiling. But what if we just like, because boiling will give us all the terms. We only care about the leading term. Imagine you boiled that out, like forced outside, inside, last. There's only one of those terms that gives you an x squared. So what's the coefficient in front of x squared on the top? 1. What's the coefficient in front of x squared in the bottom?
1.
Nice. There will be a horizontal asymptote of y equals 1. So now, I want a graph that reflects those facts and is also positive or negative at the right times. So let's just check that it's positive or negative at the right times. The only place where it can switch from positive to negative or negative to positive is either at one of the x-intercepts or at a vertical asymptote. So that means for everything to the left of negative 2, for all of those x values, it's either always positive or always negative. So if we pick a single sample point, we can get the result. What sample point would you like to pick? Yeah. What is the number that is to the left of negative 2?
Negative 3.
Negative 3 is a perfectly reasonable choice. Yeah, so let's pick some sample points. X equals negative 3. I'll give you another strategy too that will avoid any computation. So that's negative 3 plus 1, negative 3 minus 2, negative 3 plus 2, negative 3 minus 1. And remember, I don't care what the number is. I just don't care whether it's positive or negative. So let's just look at each of the things in parentheses and determine whether it's positive or whether it's negative. Negative 3 plus 1, positive or negative? Next piece. Negative. It's illegible enough I can't read it, but whatever it is, it's negative. Next piece. So I see a negative times a negative, that's positive. Divided by a negative times a negative, that's positive. So I see positive divided by positive, which is great. So that tells me that for everything to the left of x equal to negative 2, it is always positive. I'll give you another strategy. So instead of plugging in x equals 3, I'll plug in x equals, I don't know, negative 100 billion. Because I know where the horizontal asymptote is. The horizontal asymptote is at 1. If I plug in negative a billion, I should be close to 1. If a number is close to 1, is it positive or negative? Oh, positive. Negative numbers are not very close to 1. So there's a way without doing any computation, but that didn't require much computation. So here's the payoff. I'm close to that horizontal asymptote. So I'm positive, and I need to get to this vertical asymptote. Can't go to negative infinity because I would have to be negative to get there. I have to go to positive infinity. Cool. So far, so good? So next, I need to check a number between negative 2 and negative 1. What sample point would you want to pick to check something between negative 2 and negative 1? Negative 1.5 is a perfectly reasonable choice. Was it a question or just that same suggestion?
Just a suggestion.
Okay, cool. Then that was like the only thing that you could possibly have said. If you had said like negative 1.5, I would have said, why didn't you pick negative 1.5? Not that that would have been a long thing to do. X equals negative 1.5. So I'll do the same thing. Negative 1.5 plus 1. Negative 1.5 minus 2. Negative 1.5 plus 2. Negative 1.5 parentheses now, minus 1. And let's just look at each piece. This piece, positive or negative? Next piece. Negative. It's a negative minus a number. Negative 1.5 plus 2. And the last piece is negative. So, in total, is this positive or negative? Negative. So, for For all of these values, it needs to be negative. It needs to get close to plus or minus infinity. It can't be plus infinity. So there's the vertical asymptote. Nice. People feeling pretty good? Next, all numbers between -1 and +1 will either all result in positive outputs or all result in negative outputs. What's a number between 1 and -1 you could check? 0. And in fact, have we done so already? Yeah. So let's go through the Y-intercept and then just continue on our way to that vertical asymptote. All right. People feel okay so far? So how many people are wanting to object because I've just crossed through the horizontal asymptote? Yeah, it's allowed. In fact, it had to. The horizontal asymptote was the same as the Y-intercept. All right. Number between 1 and 2. Plug it in, tell me if it's positive or negative. Possibly by saying, I've recognized a pattern, and so I can do this without doing it. I hear a negative. Does that agree with people who are doing a walk? Yeah. And maybe one way to see it is from here to there, the factor that contributed to the vertical asymptote is changing sign. Now that means the whole thing has to change sign. And now I need to get to that horizontal asymptote. How does it feel? Does it feel natural enough? Nice. So I'll give you all 3 options on the next exercise. I can talk through another one. I can be quiet for a few minutes. You can talk through it, and then we can really quickly blow through it. Or we can skip it and go to the next topic, which is inequalities in rational functions. Do people want me to talk through one more example? Would people like to do one more example on there and then do it together? Okay, cool. Then I'll be quiet for a bit. Here's the next example. Do something similar. Sketch the graph of this rational function. Oh, and while you do that, this is long delayed, and there are still some people who need to take the quiz, but I feel like it's time to get this back out. Then boom. Central Pierce. And wait once. Continuing. Tunnel. Van Handel. Evelyn Kuhn. Becky Pearson. Russell Ward. On those Thursday and Friday, with you time for that 20 minutes. Yeah, send me an email if you need it. You're not even necessarily in the voting line, but not things that you do. But I'd be happy to do that. So I think it's probably the best. Thank you very much. Thank you very much. Good question. Hopefully someone else knows that.
Okay.
Thank you very much. That's good news. That's good news. How was he saying that? Oh, nice. And that is, so yeah. Just now, did I hand anyone 2 quizzes instead of just your quiz? Okay. I'll be in touch.
Okay, no worries. I have a score. It's in the grade book, so.
Okay. It would be good to know why you got that score.
Okay.
Nice. In terms of this example, how are people feeling? More time? People are clearly still walking. I can be patient. All right. Let's come together. So let's now just go through the list of things. X and Y, so X-intercepts first. I give a 1 and a -3. Does that agree? Cool. I'm going to draw this. Y-intercept.
0, 3 halves.
0, 3. Maybe I'll translate that to 1.5, not for any real reason. Vertical asymptotes. 2 and -2. Horizontal asymptote. 2. Nice. And let's see, that's bigger than 1.5. All right. So the next game is where is it positive, where is it negative? So everything to the left of -3. Is it positive or is it negative to the left of -3? What's the C-stroke like? Positive? Okay, and so, and negative? Cool, so without doing any computation, is the horizontal asymptote at a positive or a negative? Positive. So that means when y is like -100 billion, the y value should be close to 2. So I think it has to be positive. So horizontal asymptote to X-intercept. Between that X-intercept and that vertical asymptote, positive or negative? Positive? Negative? Should I discuss? Okay, so let's do it. So let's take a sample point. What is a number between -2 and -3? -2.5 will do. So let's see, that's 2 times -2.5 minus 1. -2.5 plus 3. Plus 3. -2.5 plus 2. -2.5 minus 2. And now I'll just play the game of each ingredient. Is it positive or negative? So 2 is positive. -2.5 minus 1, positive or negative? It's negative, right? It's a negative minus a negative. Next piece. Positive. Next piece. And so positive times negative times a positive, the top is negative, divided by positive. Positive or negative? Negative. So that means for all x values between -3 and -2, it has to be negative, and it has to make it to that vertical asymptote. People with me so far? So next is between -2 and 1. Have we already checked a sample point between -2 and 1? Positive or negative? Positive. So that means that this vertical asymptote here, it has to be positive. It can't be negative infinity, because that would be negative. It has to make it to that intercept.